Hello everyone, this is Balaji Kaya signing in for Brain Smart Labs. In my previous session, I had explained you how a user-defined reference variable play a very important role in Java programming. Also in the last section, I had given you an important assignment and a tricky question.
Yes!
In the tricky question part, I had asked you how many methods will make stack entries for the following program. I had also asked you to name these methods which are entering the stack one after the other for you to get a better clarity. Many of you sent a WhatsApp message to me asking should the main method be included in the stack entry or not. The answer for your silly question is of course it should be included.
Yes!
Using some basic common sense, we can say main method is also a method in Java which gets executed in our JVM. If a method has to be executed in Java, it will have to make an entry on the JVM stack. The topmost method in the stack is the method which is currently being executed. That will be executed first, followed by the execution of our other methods which is present in the below stack entries. Few more students asked me a doubt on WhatsApp saying why all methods won't pile up one above the other in stack like this. The answer for your silly question is we have written the program that way, you idiots. Again, it boils down to some basic common sense. If you ever wanted all these methods piled up one above the other, the first method should have internally invoked the second method. Likewise, the second method should have internally invoked the third method, and the third method should have internally invoked the fourth method, and so on.
Okay!
If you ever design your logic like that, as you are thinking, the stack will pile up method above a method above a method, one above the other.
Ooh!
But in this example, what you had practiced yesterday, no method is being invoked one inside the other, as all method invocations are present only inside your main method.
Oh, really?
That's the reason why as the program control moves forward, it loads a method invocation onto your stack, executes the same, and then it moves on to the next line for it to load the next method invocation onto your JVM stack.
That is correct.
Hope I have cleared all your doubts on last in first out mechanism of our JVM stack. Time to move on with our today's topic, half encapsulation and half polymorphism. ಇದೇನು ಗುರು ಹಾಫ್ ಎನ್ಕ್ಯಾಪ್ಸುಲೇಷನ್ ಹಾಫ್ ಪಾಲಿಮಾರ್ಫಿಸಮ್ ಒಳ್ಳೆ ಹಾಫ್ ವೆನಿಲಾ ಐಸ್ ಕ್ರೀಮ್ ಹಾಫ್ ಸ್ಟ್ರಾಬೆರಿ ಐಸ್ ಕ್ರೀಮ್ ಹಿಡ್ದಂಗೆ ಹೇಳ್ತೀಯಲ್ಲ ಹ್ಞೂ ಮತ್ತೆ ಇನ್ ಒನ್ ಚಾಪ್ಟರ್ ಐ ಹ್ಯಾವ್ ಟು ಕವರ್ ಬೋತ್ ದ ಟಾಪಿಕ್ಸ್ ವಾಟ್ ಎಲ್ಸ್ ಟು ಡೂ ದ ಟಾಪಿಕ್ ಆಫ್ ಎನ್ಕ್ಯಾಪ್ಸುಲೇಷನ್ ವಿ ಹ್ಯಾವ್ ಆಲ್ರೆಡಿ ಅಂಡರ್ಸ್ಟುಡ್ ನೋ ವೈ ಆರ್ ಯು ಟೀಚಿಂಗ್ ಅಸ್ ಒನ್ ಮೋರ್ ಟೈಮ್ ಅಂಡರ್ಸ್ಟುಡ್ ನಿಮ್ಮ ಜುಟ್ಟು I can challenge you anywhere till the last day of my Java session. You will be learning what is encapsulation, polymorphism, inheritance and abstraction.
Okay!
Don't think you are too smart that you have understood everything in OOPS. If you have understood everything, can you give me an instant answer for what is a class?
What is a class?
If you are asking me the question what is a class, class in Java is basically a keyword. Keywords are reserved words used to define something in a program. A class keyword in Java is used to define a user-defined template like class box, class dog, class cat, etc. Very good. In your interview also, if they ask a sudden question like this, you should answer the same way, point by point.
Okay!
Besides, you said classes used to define a user-defined template, right? My next question to you as an interviewer will be, what is a template?
What is a template?
If you ask me the question in an interview, what is a template, I will answer. A template is a mold or a lifeless plan which is used to create multiple objects in OOPS. A class template is the code written by a programmer so that you can reuse the same template again and again in Java to create multiple objects. Very good. I am so proud of you today. If you answer like this, everything tuck, 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 which teacher will not be happy, man?
Thank you very much.
In my today's class, I will be teaching you more about a class. It is very important, so please stay very attentive and start noting everything down.
Yes!
More about a class in Java.
In our previous source code file name demo.java, when we compile the file using Ctrl 1, inside our file directory system, a new file by name demo.class will be generated along with another file by name box.class, wherein both are bytecodes generated by our beloved Java compiler. If you right click the newly generated demo.class file and open it with Kava.j software, as you can see, the demo.class file contains only class demo inside it and there is no trace of class box in this bytecode file. Now if you right click the file box.class and again open it with Kava.j software, even in this file it contains the bytecode only related to class box and not a single trace of class demo can be found here, even though both the classes belong to the same source code demo.java. Java is so powerful that you can just copy this box.class file to any computer of any operating system where JRE is installed. Using this box.class file, you can create n number of box objects in those computers without the help of any source code file needed in that computer.
What? We can create box objects anywhere using this box.class, huh? You mean to say without the help of any source code? Yes. Without the help of any source code file, we can create n number of box objects in any computer in the world.
Ooh.
Just see the following illustration. You will clearly understand.
Bytecode versatility in Java.
Consider the three gentlemen, Amar, Akbar and Anthony, who want to test the bytecode versatility are coming to your PC to investigate the box.class file. To test the bytecode versatility, they will now create a new folder in your D drive which is bearing the name as different folder.
Huh? Different folder? Bere ಹೆಸರು ಸಿಗ್ಲಿಲ್ವಾ?
Now what they do in your PC is they right click and copy only box.class, paste the bytecode in a completely different location, aka the different folder. Now for their reference, they will now create three different demo source code files by name amardemo.java, akbardemo.java and antonydemo.java. Now if you see what they have written inside their source code, each one has declared a PSVM method inside which each one has created their own version of box object by initializing their own values, and they are all printing the volume of their respective box object in their respective demo code. Please note, neither Amar nor Akbar nor Anthony have declared or written any source code in their file related to class box. All they are trying to do is create a box object in their demo code using the existing box.class file. That's it. Now all three are thinking if they compile the program, they will get an error as they have not declared any class here by name class box in their respective source code. But to their surprise, as they press Ctrl 1, source code of Amar compiles fine, source code of Akbar compiles fine, and source code of Anthony also compiles absolutely fine.
Wow! So this proves we can create objects of class box without having any source code. Yes, you do not need any source code file of class box to create any object on your PC. All you need is a bytecode file to create any object of that particular type. Guru, in this computer, okay, what if someone copies the box.class file and pastes it in a different computer? Can they create the box object in that computer also? That too without using the source code file? Of course, absolutely they can do it. In whichever system you copy the bytecode file, you can create n number of box objects there in that computer where JRE is installed. Now that's the versatility of a bytecode file in Java language. Take a look at this illustration.
Let us consider Amar, Akbar and Anthony privately own a laptop, a desktop and a server. If they copy only box.class file into their machines without even touching the source code, they will be able to create box objects in their machines absolutely fine. That is, on Amar's laptop he can create any number of box objects, on Akbar's desktop he can create any number of box objects, and on Anthony's server he can create any number of box objects, all with the help of a simple copied bytecode file.
The file executes correctly everywhere because there is a Java runtime environment installed here in this laptop, also on this desktop, and also it is installed on this server for it to create multiple box objects once the box.class file gets loaded into the respective machine.
And that is the reason why, my friends, Java is so versatile in nature and developers all over the world have chosen Java language to code their applications.
That is correct.
You know why these developers still choose Java and why it became so popular then? It is because of this reason. The performance of JVM in all operating systems, all servers are so outstanding. A .class file which gets created at some corner of the globe runs on your computer or your server just like a hot knife slicing a butter.
Sweet.
No other programming language then gave this versatility feature, so the developers all over the world incorporated Java to build their programs just to make their code more versatile in nature.
Ooh.
Guru, Java's bytecode is more versatile, okay? Other languages also provided platform independency, no? But why did they not become popular? Why only Java? That is because Java had implemented OOPS in the best possible way. If Java is the most popular language today, it is because the founders of Java have implemented OOPS in the best possible way.
That is correct.
OOPS, that is object-oriented programming, is a concept which solely relies on 4 pillars. They are encapsulation, polymorphism, inheritance, and abstraction. Here encapsulation means, as I keep repeating myself, it is a process of storing information of an object inside a class template in the form of states and behaviors. If you want me to give an example again, in the modified box template class box, we have encapsulated 3 instance variables which are known as states, and we have encapsulated 3 instance methods which are known as behaviors. These 3 plus 3 states and behaviors what you are seeing here can be collectively called as members of the class by name box. Likewise, in our cat template, that is class cat, we have encapsulated 2 instance variables or states, and we have encapsulated 1 instance method by name sayMeow, also known as a behavior. These 2 states and 1 behavior in a class template can be collectively called as members of the class by name cat. Similarly, if you consider a dog template, also known as class dog, we have encapsulated 2 instance variables aka 2 states, and we have encapsulated 2 instance methods bark now and play, also known as behaviors. These 2 states and 2 behaviors in a class template can be collectively called as members of the class by name dog.
Oh, so you mean to say if we encapsulate the information inside the template and later on when we create objects using this template, this information will be passed on to the objects automatically. Yes, that is why it is named as encapsulation. It means capsulation of information in one place, just like a nucleus of any living organism capsulating the information in the form of DNA.
Ooh.
Guru, I have a doubt. Box objects created in different PCs, will it be the same or will it vary from system to system?
Box objects in different systems.
Consider a box template which is copied and pasted in different systems of Amar, Akbar and Anthony. The overall states and behaviors present in this class are known as members of the class box. Now when Amar, Akbar, Anthony create their own box objects in their own machines, Amar will get his own box object on his laptop, Akbar will get his own box object on his desktop, and Anthony will get his own box object on his server. Please note, the objects which get created will have its own set of 3 instance variables by name LB and H, that is here, here, and here. Similarly, the 3 objects will have all 3 methods declared in the template here, here, and here. This proves instance members present in a class template will be a part of every object created anywhere in this world.
Dude, I have a doubt. Can't we directly declare these members inside our main method? Why we should create objects anyway? ಎಲ್ಲ ಸಿ ಲ್ಯಾಂಗ್ವೇಜ್ ತರ ಒಂದೇ ಜಾಗದಲ್ಲಿ ಬರ್ಕೊಂಡು ಹೋಗೋದಪ್ಪ. ಲೇ ಗುಬಾಲ್ಡೋ, now you are denying the whole concept of object oriented programming. What does OOP say, man? Encapsulate your code in one class, reuse the same wherever you want by creating objects. It is such a basic thing and you are not understanding this concept. Karma. Mark my words. You can be called as number one Daddashikamani if you are not understanding this concept of encapsulation. What is a building plan? It is just a mold or an idea of a house printed on a piece of paper, right? Why we invest so much time on a plan? Can't we build a house just like that? We invest more time on a plan because we can construct multiple houses tomorrow using the same plan, right?
That is correct.
But please remember, a plan has a sofa but you cannot sit on it. A plan has a TV but you cannot watch it. A plan has a kitchen but you cannot cook your favorite food there. A plan also has a toilet but you cannot simply shit on that plan. If so, it will be no less than a toilet paper.
Gabu Ashne. Now imagine you build a real house using that plan.
Here in this house, what you have built, you can sit on the sofa any number of times. You can watch TV in this house any number of times. You can cook in the kitchen any number of times. And you can shit in the toilet any number of times till the house gets demolished.
The same logic applies to a class template and an object in Java. Why we write a class template? To create multiple objects of the same type, right?
That is correct.
Once you write a class, it's done. Tomorrow, anyone can create multiple objects using that class. But please remember, just like our house plan has a bathroom and a kitchen, our box template also has 3 variables by name LB and H and 3 methods by name print volume, fetch surface area and set box size. You can never ever use these states or behaviors inside your main method directly. To use these members inside your main method, you have to create a new object in your demo code by saying box B is equal to new box. Remember, after you create an object only, you can use or access these variables LB and H using a simple dot operator. Also remember, after you create this object only, you can invoke these methods, that is print volume, fetch surface area and set box size, anywhere outside the class. Without creation of an object, you cannot access or invoke any variable or any method anywhere outside the box template, as it is just a lifeless plan. The box object now can aramse be used inside our main method as per our advantage till the object gets completely destroyed at the end of our main method.
So if someone asks you why we have to do encapsulation, what you have to say?
If someone asks you why encapsulation, you have to answer, encapsulation, that is designing a class template, is done so that members of the class can be reused again and again inside its objects, which are totally independent from each other.
Independent? What do you mean by independent? Why do you construct your own house, man? To stay independent, right? Imagine, if everyone constructs a house to themselves, they all can stay independent from each other, no? Now as they are completely independent from each other, each person can place their sofa wherever they want, each person can watch their TV whenever they want, each person can decorate their house however they want, each person can cook their own food anything they want, and last but not the least, each person can shit in their own toilet whenever they want. Ayyo! Yena ayya, you don't know, that is the only true independence. If one goes to toilet at morning 8 o'clock, there is no hard and fast rule that everyone in all houses should go to toilet at morning 8 o'clock. ನಮ್ಮ ಮನೆ ನಮ್ಮಿಷ್ಟ, ಯಾವ ಬೇಕಿರೂ ಹೇಳ್ಬೋದು. Every house is independent from each other.
That is correct.
Similarly, if Amar is accessing variables LBH in his object, Akbar can access print volume method in his object. While Amar and Akbar are doing their jobs independently, Anthony can now access setbox size method in his object all at the same time. Remember, every object is completely independent from each other. And this is the reason why if you write some piece of code in one place inside a class, you can use that piece of code independently in many places as objects. And that's the power of OOPS. Super Guru, I have understood everything related to encapsulation now. I love you, you are my best teacher. Enough of compliments, now it is time to learn the second main pillar of OOPS, polymorphism.
Polymorphism in OOPS.
The word polymorphism is derived from two Latin words. Poly means many, morpha means form. The word polymorphism in English means many forms. In OOPS, behaviors having the same name but are having different forms in a program is known as polymorphism.
Behaviors in Java actually mean methods, and so one method in Java having the same name but many forms is known as polymorphism. Guru, one method many forms are. How? Is there any example? Take a look at this illustration.
Example of polymorphism.
Imagine there is a movie audition for the next upcoming blockbuster. Our favorite director, Mr. Steven Spielberg, calls for an audition process in one and only Universal Studios. He calls the first artist near him and asks him to enact the most funny comedy skills. The actor prepares himself waiting for the director to give him a signal. When the director says the word action, the actor starts performing his tremendously humorous comedy acting skills. Hooray! The director is completely convinced and he now clears the actor for the next round. In the next round, the director asks him to demonstrate some emotional tragedy acting skills. The actor, as usual, prepares himself waiting for the director to give him a signal. When the director says the word action, the actor starts performing his emotional tragedy acting. Hooray! The director is again satisfied seeing the actor's emotional appeal. Now he selects him for the last round where the director asks him to demonstrate horror acting skills. The actor prepares himself waiting for the director to give him a signal. When the director says the word action, the actor now starts performing his mind-blowing horror acting. Damar, director heart attack. By this illustration, we can all understand one simple thing. 3 different inputs, 3 different behaviors, but only one single command, action.
The director here gave 3 inputs and the actor performed in 3 different ways. Most importantly, the command he gave to start any of the performance was only one word, action. This is a classic example of overloading in Java. Overloading Angandren Guru. For me to teach you what is overloading, you need to create a new folder for you to start practicing.
Sweet.
Go to My Computer, D drive and then go to our workspace folder. Inside this, go to Basic Examples folder and here click on 11 OOPS, which is dedicated directory for all our OOPS programs. Inside 11 OOPS directory, create a new folder by name 02 overloading and here in this folder, create a Java file by name demo1.java where we start writing our program. Inside the file demo1.java, for a change, let us create a new class template by name test. Yes, it is class test. Now inside this class test, we declare a method by name fun, whose return type is void, and this fun method here has no input parameters defined. To add a unique flavor to this class, let us declare one more method by name voidFun with a completely different method signature. The flavors doesn't stop here, as we keep on adding one more method by name voidFun, which is no doubt of same name, but it has a totally different method signature. After this, we add one more method by name voidFun, which has a complete opposite method signature compared to the above method. These many methods are good enough for me to teach you overloading, but just for my kushi, I have decided to add one more method by name voidFun with a unique method signature, as you can see over here. The first method what we have declared here is by name fun, and it has no input parameters declared inside this method. The second method what we have declared here is also a method by name fun, which has one input parameter declared, which is of type integer. The third method what we have declared here is again a method by name fun, which has two input parameters declared of type integer and double. The fourth method what we have declared here is again a method by name fun, whose input parameters are opposite to the above method, that is double and an integer, which changes the method signature altogether. The fifth method what we have declared here is again a method by name fun, which has one input parameter of type double, and it has a different signature compared to the above methods. Now inside the main class demo1, our job is to create an object of the above test template, and after creating the object of test, we invoke any one of the above fun method randomly as seen over here. Let's see. Let me first invoke the fun method by passing the inputs as 5 and 18.2. Compile the file demo1.java by pressing the buttons Ctrl 1 and boom. You see, you haven't got any compilation errors over here, as the compilers verified the methods not by their name but by their signature. If no duplicate signatures are found, the compiler will give our code a clean go ahead with zero compilation errors. Now here lies the biggest question of the century. Which fun method below will now be executed? Is it A, the first fun method with no input parameters? Or is it B, the second fun method with one input parameter of type int? Or is it C, the third fun method whose input parameters are int and double? Or is it D, the fourth fun method whose input parameters are double and int? Or is it E, the fifth fun method with only one input parameter, which is of type double? There is only one way to find out. Run the program by pressing Ctrl 2. Kaboom! It is the third fun method with two input parameters which are of type int and double. The reason is simple. This fun method what you are seeing now exactly matches with the input arguments passed, that is integer and double. Now just for fun's sake, to test this example once again, let us try to invoke the fun method one more time. This time let us invoke by passing 22.05 as our input. Now as you press Ctrl 1 to compile the file, this will give us no compilation errors as expected before. Once the compilation is done, run the code by pressing Ctrl 2 and kaboom! You see, the method with one input parameter of type double is executed. If you ask me the reason why this method out of all the fun methods available got executed, it is because the fun method below what you are seeing is exactly matching with the input arguments passed, that is a double literal 22.05.
Very well then. Here is a small assignment for you.
It is now your job to invoke all the above fun methods by passing various sets of inputs as seen over here to get a first-hand experience on what is overloading.
Sweet.
Super Guru. Now what should we answer in our interviews if they ask us what is overloading?
In your interviews, if at all they ask you a question what is overloading, which is no doubt a sure shot interview question, your answer should be: overloading is a type of polymorphism wherein the compiler allows two or more methods having the same name to coexist in a single class template, as they are all having different method signatures.
And if they ask you what is a method signature, your answer should be: a method signature is an entity used by our Java compiler to differentiate two or more methods of the same name based on its input parameter description. That is, number of parameters, order of parameters, and data types of parameters used.
ಅಯ್ಯ ಓವರ್ಲೋಡಿಂಗ್ ಅಂದರೆ ಇಷ್ಟೇನಾ? I thought it was some very big concept.
It is very simple, and when I tried out your example, the whole concept was just a piece of cake. You tried out very well as you are a good student, but they should try out, no? These people outside the screens are so lazy, seeing the code only they will simply nod their head thinking as though they have understood everything. Forget about coding, they will not even maintain proper notes to start with. ಹೌದಾ, ನಿಜಾನೇನ್ರೋ? ನೋಟ್ಸ್ ಕೂಡ ಮೇಂಟೈನ್ ಮಾಡಲ್ವಾ ನೀವು? I know the fate of these students who are not making notes. In the interview, if they ask some tough question or some definition, how will they answer? ತಿಕ್ಕ ಹೊಡೆಸ್ಕೊಳ್ಳಿ ನನ್ನ ಮಕ್ಕಳು, ಅವಾಗಲೇ ಬುದ್ಧಿ ಬರೋದು. Unless they fail in 1 or 2 interviews, they will never realize the importance of maintaining notes.
Oh no!
In your interviews, all questions will be asked to you in English. Just by knowing the concept, if you are not able to present it properly, means how will the interviewer know that you know the concept? Correct, Guru. That's why I maintain proper notes regularly and code every example what you teach. I have decided, before going to any interview, I will by heart all the definitions so that my understanding will be properly conveyed to the interviewer. Bravo! Good. Continue doing that. Janamari. Now let us see more about overloading, shall we?
Yes!
In our demo code, the method invocation which invoked the third method, as you can notice, the first input what we passed is an integer literal 5 and the second input what we passed is a double precision floating point value 18.2. The above fun method invocation triggered only the third method because value 5 matches with the first parameter of type int and value 18.2 matches with the second parameter of type double. This dictated the JVM to execute only the third method whose fate was decided during the compilation of the program. If you closely notice, the below method also contains the same input parameters but with a different order. But the JVM did not invoke this method because as the signature did not match with the below method what you can see here. This principle can be applied to another example over here. In our method invocation t.fun 22.05, the input we are passing to our fun method is of type double. This invocation triggered only by our last method here because of a simple reason. The value of 22.05 matches with the data type double in the following fun method. This dictated the JVM to invoke only the last fun method and not the one which is present above, even though both methods are having only one single input parameter. So this is how overloading will work in Java. But bro, I have one major doubt. Suppose there is a first method whose input parameter is int a. Below that there is one more method which is having the same name whose input parameter is int b. Can this be called method overloading in Java? Le Gubaldo, the example what you are narrating is not method overloading, it is compilation error. You know, compilation error. How? Take a look over here.
Confusion alert.
Many of my students confuse this with overloading, but it is a clean case of compilation error. In your program, suppose you are having a class by name test, and inside test we have a first method by name fun whose input parameter is declared as int a. Suppose below that method we have one more method by name void fun, and in this method it has an input parameter declared as int b. What you are seeing now, it is not method overloading, it is a pure case of compilation error. Reason being, the method signature of our above method is same as the method signature of our below method. Two methods of same signature cannot coexist in a single class. That's the basic fundamental rule in Java, and I had taught you this while I was teaching you methods in chapter 14 if I am not wrong.
Yes!
Let us take one more example for that matter.
In our class test, if we write the first method as fun, it will have two input parameters declared int and double respectively. In the same class, if there is a second method having the same name, it can have the input parameters as double and int as it is ulta compared to the above method. The compiler gives us a green signal for this code even though both methods are having the same input parameters jumbled around. Reason being, method signature of the first method fun is int comma double, whereas method signature for the second method fun is double comma int. As the order of the parameters matter a lot for the Java compiler, the compiler will allow this method to stay in our class. Suppose if we change the order of the parameters in this method like this, the compiler will slap you on the face as two methods present in the class are of same signature and they cannot coexist together inside a single Java class.
Many students have a common doubt about return types. They feel the return type is included in the method signature, but no.
If you see the next example, the first method fun is having void as its return type with no input parameters. The second method fun is having int as its return type, and even this method does not have any input parameters defined. As the signatures of both methods are one and the same with zero input parameters, if we compile this code, we will get a compilation error. Reason is simple. Method signature is completely independent with respect to return type in Java.
And this is for the students who have not paid attention while I was teaching you methods. When you declare a return type at start of a method, please declare a valid return statement at every logical end of that method.
Okay.
If a method has only one logical end, which is the most common scenario, make sure you have mentioned a valid return statement at the end of that method. Well, if you do not mention any return statement, the compiler will slap you left and right by giving you a compilation error. The value you are returning in the last line must be what? It should be of same data type as declared in your return type. If you keep these points in your mind, you will be a pro in declaring and invoking a method.
Yes!
Okay, time has come for me to end this session. I know this session would be a little hectic for you, but if you work out all the examples and see the video one more time, it is the easiest topic you have ever seen till today. Do work out all the assignments I have given you, and please make proper notes or else you will end up in soup later. Do text us your doubts on WhatsApp if you have any so that we can solve it for you. Remember, you understanding the subject is our topmost priority. Do share this video series with your friends and encourage them to buy it on our website www.brainsmartlabs.com. This will give us a financial aid for us to bring more and more programming videos for you. Do like our Facebook page to receive more updates on our new upcoming video series. Till then, this is Balaji Kaya signing out, and you know what to do. Muchkond code ಮಾಡಿ bye bye.